4.3, Writing Functions. In this section, we are going to be looking at different function scenarios where we will be writing out equations and recognizing independent versus dependent situations. Sometimes they'll ask you to identify independent variables and dependent variables in questions through the book. An independent variable is an input of a function. Dependent variables are the output of a function. So the value of the dependent variable depends on or is a function of the independent variable. Some more things to think about with writing functions. When you're working with independent and dependent functions, we can write what's called a function rule. And what a function rule is an algebraic expression that defines a function. You see too what's called function notation. So if x is representing an independent variable, y is representing a dependent variable, then a function notation for y is f of x, read f of x, where f names the function. So we're going to look at some function notations coming up here, but this is a good definition to know that when you're working with function notation, for y, it's represented as f of x. Here is an example. We have since y equals f of x, this is a situation with the algebraic expression. Sarah's earnings is y equals f of x, and this can be rewritten in a function notation form by substituting f of x in for y. So you have f of x equals 5x. Sometimes functions are written using y, and sometimes they are written using f of x. So let's get into some examples of working with functions and recognizing independent and dependent variables. So looking at example number 1, it says determine a relationship between the x and y values in the relation. We have 1, 3, 2, 6, 3, 9, 4, 12. And they want us to write out an equation representing this relation taking place right here. So I have 1 and 3, 2 and 6, 3 and 9, 4 and 12. So what this is saying, you have x is your input, y is your output. How do you get from 1 to 3? Well, 1 to 3, isn't 1 times 3, 3? Yes. Let's look at this. 2 times 3 equals 6. 3 times 3 gives me 9. 4 times 3 equals 12. Do we recognize a pattern going on with this input and output situation? Yes, if you multiply each x value, the input, by 3, you get the output, which is y. So when I look at writing an equation for this situation, let me show you what this would look like. So looking at the y values, like I just showed you, 3, 6, 9, 12, when multiplying the x values by 3, this gives you the y value. So the answer to this is y equals 3x. That is the equation that represents our input and output values. If it helps to write it as a table like I just showed you, then do that with 1, 3, 2, 6, 3, 9, 4, and 12, and thinking what you can multiply by or add or subtract or divide. You're not always going to be multiplying your x values to get your y values. Here's another example. Example number 2, it says identify the independent and dependent variables. Remember, independent is your input. Dependent variables are your output. A lot of times we think the input, that's y, the output the input is X, the output is Y. So here's some situations. A company charges $10 per hour to rent a jackhammer. So what we have to determine is our independent and dependent variables. So what is going to be my input X? Well, my input is time. A company charges $10 an hour. So depending on how many hours they put in, that's going to determine how much they make. So the dependent is cost. Independent time, dependent cost. The more time you put in, at the end, the more money you make. Input, output. Let's look at the next example. Apples cost 99 cents per pound. So we have to think of our independent and dependent variable. Well, what's going to be my input? My input's going to be the pounds. The output's going to be the cost. So depending on how many pounds the apples weigh is going to determine the cost of your apples. So pounds are X, dependent cost is going to be your Y. In your bookwork, you will be identifying, they will be asking you to identify independent and dependent variables. Here we go, example number 3. It says identify the independent and dependent variables and then write an equation in function notation for each situation. Remember, function notation is f of x. Okay, and we also need to identify our input and output variables. So Stephen buys lettuce that cost $1.69 per pound. So what is going to be my input? What is going to be my output? So I think my input, my independent, is going to be pounds. My dependent is going to be cost. And then we have to think of if it's $1.69 per pound, if we take $1.69 per pound and multiply that by my variable, it's going to give me the total cost. So let's check our answer here and show you. So independent is pounds, dependent is cost. When I write my function notation, it's going to be f of x, or we can think of this as y, equals 1.69 times x. So this equation matches the situation. We've labeled our independent and dependent variables. And this is in the function notation form. Let's look at our next example. It says an amusement park charges $6 parking fee plus $29.99 per person. So we need to think of our independent and dependent variable. So I think our independent variable is the number of people attending, which is going to be our dependent, which is going to be the total cost altogether. And then we need to set up an equation that includes the parking fee plus the $29.99 per person going. So when we think of our answer for this, our independent is people. The number of people going determines the cost of how much it's going to cost us to go to the amusement park. If you have a $6 parking fee plus the $29.99 per person, X would represent the person. So this is the function notation. We've labeled our independent and dependent variables. Last example here for section 4.3. Now they're giving us a function notation and we need to solve here. It says evaluate each function for the given input values. So here we have function notation for h of c. Here's the equation, 2 times c minus 1. And they want us to find our h of c when c equals 1 and c equals -3. So the way we go about solving this is we have to solve it 2 different times, where we first plug in 1 for c and then we plug in -3 for c. So how I will set this up for the first part is h of c equals 2 times what's my first c is 1 minus 1. And when I solve this, 2 times 1 is 2 minus 1. So h of c equals 2 minus 1 is 1. Okay, that's the first answer. Now we need to solve using the same equation, but now c is negative 3. So we have h of c equals 2 times negative 3 minus 1. When we're solving, we need to think of orders of operation. We'd multiply first. 2 times negative 3 gives me negative 6, so h of c equals negative 6 minus 1. Negative 6 minus 1 is going to give me h of c equals negative 7. So when I evaluated for the function, we have our input is 1, our output is 1, input negative 3, output is negative 7. So I've solved. Let's look at the next example, which is very similar, just a different equation. There needs to be an equal sign here too, with different values for x. So we have f of x equals 3x plus 2. Find f of x when x equals 7 and x equals negative 4. So I will set this up. F of x equals 3. My first x is 7, so 3 times 7 plus 2. F of x equals 21 plus 2, which equals 23. That's my first answer. But then I have to solve it now for when x is negative 4. So I have f of x equals 3 times negative 4, plus 2. Again, solving orders of operation. 3 times negative 4 is negative 12, plus 2. So f of x equals negative 10. So when we look at this function, when we have an input of 7, output would be 23, given this equation, or when input is negative 4, output is negative 10.